This is part 2 of a series of 3 videos that will walk you through the commissioning of the Siemens FS230 clamp-on ultrasonic transmitter. Please be sure that you've watched part 1 prior to viewing this video. A pipe with a liner is something that you can have with a clamp-on ultrasonic meter. If you have a liner, you're going to be asked for additional information. For this video, we're going to say no because most cases you're not going to have a lined pipe. But if you do, just hit yes, and then follow the instructions and make your selections based on your actual application. The next choice that you get is disturbed flow. Disturbed flow is what we used to call, for the old FUS, FUH, FUG transmitters, pipe configuration. However, with the FS230, disturbed flow now allows you to configure both upstream and downstream conditions. So, if you've got disturbed flow, you would select yes, and then you would put in whatever type of disturbed flow conditions you were dealing with, whether it's an upstream condition, a downstream condition, or whatever it might be. Once you put in your particulars, the transmitter will do the patented correction that Siemens offers for clamp-on ultrasonic flow to help maximize the performance even if you don't have optimal flow conditions. In this case, we're going to leave upstream and downstream as a straight run with no problems, and we'll move down and select next. Then select yes. Next, we're going to make the sensor selection. You may recall that the FUS, FUH, FUG transmitters would actually make the sensor selection for you. However, in the case of the FS230, you have to stipulate what your sensors are. The sensor selections are as follows. FSS200 high precision, which is the old 1011 GC high precision. The FSS200/1011 universal is the previous 1011 universal selection. The FSS200/991 is the older 991 high temperature, and the 1011 high precision is the high precision liquid sensors. For our example, we're going to select the first one, the FSS200 high precision. Once you right-click on that, you just move down and select your sensor. I'm going to select the C2H sensor, and again, once I find that, I right-click on it. And just to reiterate, you can go up or down to find your sensor. If you're starting at the A's and you want to select one of the larger sensors, you can actually move up through the screen and get to it maybe a little bit quicker than moving down through the page until you find what you're looking for. Once you find the C2H, hit the right arrow, and then you can move on to the next selection. You can then enable temperature if required, and then go to the temperature code to make sure it aligns with your process temperature requirements. What you're doing in temperature code is selecting whether it's a T1, a T2, or a T3 level temperature based on your operating conditions. You would then proceed to do the select spacing offset. Now most of the time that's going to be nom or nominal, and that'll be sufficient for this one. The last thing you're going to want to do on this screen is to put in your cable length requirements. Here again, you're just going to enter a number. Keeping in mind that we designated length in inches earlier in the process, you want to enter a cable length in inches. If you want 20 feet of cable, you're going to want to put in 240 inches, which is what we're going to enter here. And then once you've entered the 240 inches, you select OK. From here, go down and select Next. The next step is the medium settings. When you select yes, you will get a long listing of different process mediums. For our example, we're going to pick diesel fuel. Just as before, you can go up or down to find the process medium you're looking for. Again, in this case, I'm looking for diesel fuel, so I'll move down until I find diesel fuel, and then right-click. Once that's selected, you can see various parameters. There is a default process temperature that's selected based on the process that you put in. If you want to change that temperature, you can, and the transmitter will make corrections accordingly. Your viscosity is the default viscosity for the process that you've selected, but you can manually put in viscosity information, as you can also do with density. In this case, we're going to stay with the process temperature of 68. We're also going to stay with the viscosity and the density as it is, and then we'll click on Next. This is the point where you select what your path configuration looks like. In other words, are you using a 1, 2, 3, or 4-path design? In our case, we're going to deal with a single path, which is what you're going to see most applications for ultrasonic clamp-on. Right-click on Path 1, and then move down and click on Save Settings. Once you do that and select the path, it calculates the necessary geometries and then gives you the choice of traverses. We're going to make this a 2 traverse. What does 2 traverse mean? To traverse basically means that your sensors are on the same plane as each other, which means if you're using a mounting hardware frame, for example, you're basically going to have the two sensors on the same side of the pipe. With this configuration, the clamp-on meter is going to bounce the signal off of the far side of the pipe and then bring it back to the same side of the pipe it just left. The transit time signal is going across the pipe twice, being sent out from one of the sensors, bounced off the opposite wall, and then it's going to go back up to the other sensor that is acting as a receiver. Then this is replicated but in the other direction. To traverse is used in the majority of installations. The SiWare sizing tool, now replaced with the FS230 sizing tool, will tell you what your traverse should be, and hopefully you've used that for sizing software and you've selected accordingly. Again, in this case, we're going to pick to traverse. After you select this, the transmitter will perform a calculation that will allow for proper spacing for the optimum performance based on the information that you've provided up until now. Since we're comfortable with the information we've provided, we're going to move down to Next and right-click. We will also click on Next on screen 40 and the Start Measurement, screen 36, to move to Sensor Settings. Finished. We've reached the point where we can start putting in some process display values. There are up to 6 different process values that you can configure for the device display. We will use process value 1 as an example of what you can do. In our case, we're going to select volumetric flow. I will then select gallons per minute as my preferred flow unit. For our maximum flow rate, we're going to leave it at the 125 gallons per minute. You would then go through the same process with process values 2, 3, 4, 5, and 6, depending on how many you want to set up. Once you've set up all the process values that you want, go all the way to the bottom, select Next, and move on. Our next step is to set up our totalizers. With the FS230, there are 3 different totalizers that can be configured. We're going to use totalizer 1 as an example. At this point, let's say we want this one to be process value. If we don't want it to be volumetric flow process value, it can be changed. We can also make changes to units as well as designating the direction for totalization. We can designate the direction for totalizing to be forward, reverse, or in both directions. And then last but not least, we want to go down and look at the fail-safe behavior. The fail-safe behavior for totalizing has 3 choices. Those choices are run, hold, and memory. To give you a quick rundown, selecting run has the totalization continuing even though there's potentially bad input information. It will continue to give you whatever it's seeing even if the value of that information is not considered good. If you select hold, then the totalization just stops exactly where it was when it encountered a problem. It just stops totalizing at that point. Lastly, if you choose memory, it continues to totalize. However, it bases the totalization on the last good value that it received. So if you're flowing at a certain rate, when it goes into the failsafe, it's going to totalize at that rate until the fault is cleared, and then it will go back to running the actual good value. Those are the 3 choices that you have, and your selection is going to be based on your application. For this exercise, we'll just keep it as run. My name is Jack Roushey. Hopefully this has been a good educational experience for you. We recommend you proceed on and view part 3 of this series for a complete overview of the FS230 setup.